So on page 5, the first example is to write an algebraic expression to represent each verbal expression. There are lots of words in math that represent different things. Here is but a short list of them right here. If you need to pause to look over these, go ahead and do so. Otherwise, I'm going to shrink it back up. And for example, 1a, it says 2 more than 4 times the cube of a number. So there are some of those special words that we see here. We see the words more than. I see times. And I do see a word that was not on that list, and cube. And what does it mean to cube something? Well, cubing something is to the 3rd power, just like squaring something is to the 2nd power. And then whenever it says a number, this is your variable. So 2 more than 4 times the cube of a number. Whenever you see the word than, that usually means that part is going to go to the end of the problem. So we'll have plus 2 at the end of the expression. And then 4 times the cube of a number would be 4. And the cube of a number would be x to the 3rd power. Second part of that says to find the quotient of 5 less than a number and 12. So quotient is one of those special words. Quotient is a division answer. There's less than, which means subtraction. There's the word a number, a phrase a number, and 12. So we do quotients in algebra as fractions. So 5 less than a number would be your variable, and I don't care which variable you pick. I always use x. So x minus 5 divided by 12 like this. Now that is different than if you wrote it like this. If you wrote x minus 5 divided by 12, on this one over here, you would do the number minus 5 first and take that answer divided by 12. But on this over here, if you followed order of operations, you would divide 5 by 12 first and then take x minus that number. So these are 2 different ones, and the one that's circled is the one that's correct. So that was example number 1. Example number 2 is in reverse. They give you a verbal sentence and you change it to a mathematical sentence. They change it to a verbal expression. These are probably the easier ones because you could literally write it out like part A could be written out as 6 times x is 72. That would be perfectly fine. Or you can see how they wrote it. They wrote it as the product of 6 and a number is 72. Part B could have been written as the sum. Well, I guess they wrote it as the sum. They could be written as the total of n and 15 is 91. That would be fine too. But there's lots of different ways you could write the answers on example 1 and example number 2. Then we get to the meat of it, which is solving equations. And that's what we do a lot of, is trying to figure out what the variable equals. So remember on an equation that you got to keep things balanced. Whatever you do on one side of the equation, you got to do the same thing on the other side. To solve this equation, we will add 3.24 to both sides. And you would get n equal to, and then these would cancel each other out, and you would get 45.34. On part B on that example, it's negative 5/8 x equals 20. In order to do that, a lot of people say, well, I need to divide by negative 5/8, and that's perfectly fine, and that will give you the correct answer. But another way of dividing by 5/8, whoops, don't need to do that. Another way of dividing by 5/8 is to multiply by the reciprocal, which is what you get when you flip it over, which is 8/5. And that's probably more important to understand how to do that, because there will be times where you have to do this with variables, and there's not a variable button on your calculator. So understanding that dividing is the same as multiplying by the reciprocal is important. So on this one, we are going to multiply both sides times negative 8/5. And I'm not sure why it did that. So times, come on. It's being ornery. There we go. So multiply by negative 8/5 on that side. And we're going to multiply by negative 8/5 on this side. And when you do that, the 5's cancel, the 8's cancel. And so you're left with x equal to whatever 20 times negative 8/5 is. And I know you can do it on a calculator, but let's go ahead and talk about why the answer it is. The way you multiply a whole number times a fraction is you put it over 1, and you multiply the top numbers together and the bottom numbers together. So you would get negative 160 on the top over 5 on the bottom, and that simplifies to negative 32. So don't rely on your calculator. You've got to understand how to do these when we do problems like this with multiple variables. Picking up the pace a little bit, we got example number 5. We're solving this for x. This is a multi-step equation, so we're going to start out by doing the distributive property. 5 times x is 5x. 5 times 3 is 15. And then do 2 times 1, which is 2. And 2 times negative x is negative 2x, and that equals 14. We'll combine like terms. 5x and negative 2x would be 3x. So that's 5x, and plus negative 2x is 3x. And then 15 plus 2 is 17. And I always cross things out when I do problems like this, so I remember that I've already used them. Equals 14. And then we subtract 17 from both sides. So 3x equals negative 3, and then divide by this 3 on both sides, and we get x equal to negative 1. And that's example number 5. And then finally, example number 6. This is where you get one of these multivariate questions. It says the formula of a surface area S of a cylinder is S equals 2 pi r squared plus 2 pi r h. I'll write that out again. Where r is the radius of the base and h is the height of the cylinder, solve the formula for h. So on this one, we want to get h by itself. So where's the h? Well, the h is over here. I want to get that h by itself. So I'm going to eliminate anything that does not contain with the h, any term without an h, by addition or subtraction, and that's this term right here. So I will subtract 2 pi rh from both sides. Excuse me, let's try that again. Got to erase that. It's not 2 pi rh, it's actually 2 pi r squared. So that eliminates the 2 pi r squared, so I get s minus 2 pi r squared, because I can't actually put those together. They're not like terms, equals 2 pi r h. And then I'm going to divide, since this is all multiplication over here, I'm going to divide by 2 pi r to eliminate the 2 pi r's. So divide by 2 pi r on both sides. And so the answer is h equals just this, s minus 2 pi r squared over 2 pi r. And it's very tempting to try to cancel out the 2's and cancel out the pi's, cancel out the r's, and say the answer is just s, but that's actually not true, because when there is subtraction involved in either the numerator or the denominator, you can't just cancel things out simply top and bottom like that. I'll give you a simpler example. If I had a question like x plus 2 over x plus 1, and if we thought, this is wrong by the way, if we thought we could just cancel out the x's, that means that the answer would be 2 over 1, which has to be 2. So what a person would be saying is it doesn't matter what x is, the answer is always 2, and that's not true. If you pick any number to plug in for x, let's say 3, is 3 plus 2 over 3 plus 1, does that equal 2? And it does not, because 3 plus 2 is 5, 3 plus 1 is 4, and that is clearly not a 2. So that's why this is the correct answer. There's nothing else to simplify.